Welcome. Let me address a question that's come up. Do you want to teach memorization and doing in an algebra class, or do you want to teach thinking and doing? I really believe in the term nutting your way through stuff. So a standard topic in Algebra 2 is quadratics. They're studied for a very, very long time. Kids are meant to know them backwards and forwards and know all sorts of formulas for them and all the rest. Let me show you what I do with my classes. We certainly do study quadratics. I'm required to teach that. And let me just give you the list of things that my kids know about quadratics before I give them a question like the following thing that appears in textbooks left, right, and center. Okay, we certainly know that if you graph y equals x squared, you get a basic, nice, symmetrical U-shaped graph. And my kids also know that we can mess around with the form. We do something like, 3x minus 2 squared plus 5. This is telling my kids that 2 is now behaving like 0. So whatever it's doing at 0 before is now doing it at x equals 2. This 3 is multiplying 3x squared, basically messed around x squared, I admit, but it's made it steeper, and everything's been shifted up 5 units. So my kids know that this graph is now basically of the shape here, a little bit steeper than before, with x equals 2 behaving like 0, everything pushed up 5 units. My kids know that. What else do my kids know? They know how to complete the square. Ax squared plus bx plus c. It's not actually obvious that adding a U-shaped curve and a straight line should be another perfect U-shaped curve, but after doing a little algebra, we've learnt that if we arrange things so that this term is a perfect square, if we're sticking with whole numbers, and this term here is even, then it's actually easier to write this in the form, something like this, which is, again, a transformed version of y equals x squared. Right, so my kids know that all quadratic curves are symmetrical U-shapes. They know how to recognize a curve in this form and just see what is just basically y equals x squared messed around with, and they know how to actually do the algebra, completing the square if they ever need to do that. That's it. I never mentioned the quadratic formula. Oh, actually I do. I do. We do talk about it, but I don't expect my kids to know it. Things like find the line of symmetry, never talked about that. Things like rewrite the equation in vertex form. Who knows what vertex form means? Kids will have no clue. But I'll give them a question like this nonetheless. And here's how my kids will nut their way through it, which I believe is a valuable exercise in its own right. Yes, the topic is kind of dreary, but what the thinking I'm putting behind it, I like to believe is not. All right, anyhow, I've got no control over this curriculum. I have to teach this stuff. Anyhow, here goes. My kids will look at y equals 2x squared minus 8x plus 6, see a whole host of questions they're meant to do with this, and say to themselves, well, there's no reason I have to do anything in order. I can do it in any order I like. Number one, there's a nice adult choice. Don't do things the old presenter do them. Do them in the orders you like. My kids also know that if you have a picture often says 1,000 words. So let's go straight for D. Let's actually draw a picture of this stuff. And, whoops, sorry, I've lost my pen. Here we go. So let's focus on D. We've got y equals 2x squared minus 8x plus 6. My kids know that's going to be a symmetrical U-shaped graph. In fact, if you can find two symmetrical points on this graph, then you're pretty much golden. You're basically there with all the work. And the way my kids will do that is they'll focus, we're looking for interesting x values. So let's focus on this x part. So, I described this in my other videos. That's why I'm sort of going fast through this. But they say, okay, look at 2 minus 8x, and ignore the 6 at the moment. It just shifts things up or down. Let's rewrite that as, pull out an x, so I get 2x minus 8, and still the plus 6. So that tells me x equals 0 is interesting, and x equals 4 is interesting. In fact, if I put in x equals 0, out comes y equals 6. And I put in x equals 4, I can also see out comes y equals 0 plus 6. There we are. I've basically got the graph. I can now see that this is a symmetrical U-shaped graph, which at 0 is 6 high, at 4 is also 6 high. Great. I guess my kids do know that the steepness is 2, what does steepness mean, but it's positive, so it's actually going to be a positive U-shaped graph. The trouble is I don't know if it stays above the x-axis, just touches the x-axis, or dips below the x-axis. Well, I certainly know that middle point, 2, is where the vertex is between 0 and 4. Just because it's symmetrical, it has to be 2 is where the vertex lies. So to find out how high the graph is at x equals 2, why don't we just plug in x equals 2? Okay, so if x is 2, then y is going to be 2 times 4, that's 8, minus 16, negative 8, plus 6 is going to be negative 2. Hopefully I did that actually correctly, because I'm really not actually that good at math, at least when it comes to arithmetic. 16, negative 2. All right, so the graph must be a U-shaped graph, like so. Bingo. Sketch. Part D done. Well, I guess now actually a lot of it's pretty easy. Oh, I might as well just fit on this negative 2. Right. I've got atrocious handwriting. You can see about that. You can see a lot of comments complain about my handwriting. A lot of comments explain about the speed I speak as well. So I guess I'm just being bad all around. All right, but a picture speaks 1,000 words, like I said. What's the line of symmetry? Never heard the word line of symmetry before, but if I just use my common sense, line of symmetry must be the line that makes about which the symmetry occurs. Line of symmetry must be the vertical line x equals 2. All right, so never having heard that term before, I'm just going to guess that's what it means. Anything else that's obvious? I guess the vertex is now obvious. The vertex is at x equals 2, and I guess we worked out the y value there is -2. Bingo, part A has just fallen into place. We write the quadratic in vertex form. Don't know what vertex form means, but I can guess it must be some form of the algebra that makes the vertex pretty darn clear. Well, look, if I look at the picture, I see this really is basically the y equals x squared curve that's been messed around with. In fact, it's made so that 2 behaves like 0, so I guess it's basically y equals x minus 2 squared. I can see that everything's shifted down 2 units, must be down 2, and there's some steepness involved, and I don't know what the steepness is. Actually, if I'm really clever, I can see if I expanded this out, the steepness must be 2. So I've actually got the answer right there. And I'm going to guess this is what vertex form is, because I've actually made very explicitly clear what the vertex is. So I'm going to guess that's what vertex form means. If I didn't see that cleverness, I could just, if the algebra would tell me a would have to be 2, I can just plug in some point to find out what a is. In fact, let's plug in x equals 0, y equals 6. So 6 equals 4a minus 2. Yep, that gives me a is indeed 2. So I bet vertex form means y equals 2, x minus 2 squared minus 2. Lots of 2's there. All right, C, done. Okay, where does the quadratic cross the x-axis? That seems hard. Find where the quadratic crosses the y-axis. Oh, it's right there, y equals 6. Done. All right, I guess I have to do a little bit of work for E. All right, so this is the algebra part. Yes, my kids have actually played with the algebra, as I mentioned, so we have to go through the algebra, unfortunately, and do the work. So basically, I want to find out where 2x squared minus 8x plus 6 equals 0. My kids and I have played around with these for a while. We discovered that this number is a nice perfect square, would be grand. Right now, 2x squared is pretty awkward. I could deal with root 2 if I want. I'm not going to. I'm going to multiply everything by 2, because then I'll have 4x squared minus 16x plus 12 equals 0. Actually, if I was clever, I would have divided everything by 2, but let's go with this route. I don't have to be smart all the time. Okay, let's see. So this wants to be a perfect square. So that tells me I've got one piece that's 4x squared, must be from 2x and 2x. I've got two pieces that have to somehow combine symmetrically to be negative 16x. I guess it has to be negative 8x and negative 8x. So something times 2x is negative 8x, negative 4, negative 4. This number better be 16, which is annoying because I've got 12. But we can be our own people. I want 16. Let's add 4 to both sides. So this now tells me 4x squared minus 16x plus 16 equals 4. That is, if I look at the picture, 2x minus 4 squared is 4. So 2x minus 4 is 2 or negative 2, taking square roots on both sides. That is 2x is either 6 or 2. Dividing by 2, x is 3 or 1. Actually, this is a very nice graph. So where's across the x-axis? S equals 3 and x equals 1. Bad handwriting. I lose points for handwriting. All right. Did you ever see x equals negative b over 2a anywhere in this work? Did you ever see x equals negative b plus minus square root of b squared minus 4ac 2a? No. I will not have my kids memorize these formulas. In fact, any question that appears on a standardized test I've ever seen doesn't actually require kids to have these formulas in their heads. I don't require my kids to have these formulas in their heads. We certainly discuss them. I go through them. We talk about what the rest of the world probably does to answer these questions. But they can just nut their way through stuff. Now, one complaint I'll get about that is that what I've done is a little bit slower than actually just plugging and chugging into a formula. Okay. If speed is the goal, then go ahead and memorize those formulas, because if speed and getting answers is your goal, go for it. But I'd much rather give my kids a problem like this, say, do stuff with it. And here's the stuff suggested. All the terms need not be defined beforehand. Just use common sense to nut your way through what you think those terms could mean. If I could teach my students, even with the rigid algebra curriculum, to be free thinkers like this and use common sense and just nut their way through stuff, I think I'm doing a good service to the world by creating a generation of people that are willing to just take on something that's unfamiliar and just work with it and see what they can make happen with it. And most often, they'll be right. All right, thanks so much. I'll do another example in my next video of something similar to this. All right, thanks so much.